Good morning, everyone. My name is Ron Dominguez. I'm the Service Delivery Manager for Microsoft. My primary responsibility is ensuring that our collaborative support model ensures that all of our customers that come to Microsoft Azure have a seamless support experience with all of our partners. Primarily, we're here today to focus on SUSE. We've also brought a few colleagues with me to assist with this session. Next to me, I have our Senior Support Planner. Her name is Abhirami Iyer. She is responsible for all of our support models and for the end-to-end customer experiences dealing with all of our partnerships, such as SUSE. We also brought with us today one of our Microsoft support escalation engineers. His name is Rakesh Jingapali. Not only does he work on our case resolution, he's also dedicated to our customer experiences, primarily focused on the SUSE ecosystem. Next, we have one of our own, or one of your own, SUSE engineers. He's our dedicated support engineer, Grant Markroff. He is actually one of a unique people at Microsoft because he sits with us with our Azure support environment, working day to day with all of our support engineers. I'd like to discuss our agenda that we have here today. We really want to cover a lot of the topics which primarily focus on the Microsoft and SUSE partnership. We're going to have a good talk about our collaborative support, what it means, how it impacts our customers, and how it benefits all of our partnerships. We, of course, have a demo, so we want to provision a SUSE Linux VM. And although there are many ways to deploy VMs in the Azure environment, we're going to go ahead and focus on Terraform today and show you how you can do that in our environment. The other thing we're actually excited about is all the SUSE products that can be used in the Azure workplace and what the benefits are of bringing those workloads over to Azure. Next, we have had many years partnership with SUSE, and so we want to share some of the success stories that our collaborative efforts have brought. And then finally, at the end of the session, we are going to do a panel Q&A. But if you have any questions during the session, please feel free to speak up and we'll answer them at that time. Some of the key highlights that we want to bring to everyone's attention about the partnership between SUSE and Microsoft are the fact that SUSE was the very first one to create a Linux kernel that was optimized to be used on Azure. If you're deploying SUSE HPC images from our Azure Marketplace, we do have a specific image created already that will take full benefit of any InfiniBand interface. And then if you really have the desire to use SQL on your SUSE machines, we have created a Linux image, which is the SUSE Linux Enterprise Server /12 with SP2, pre-configured with SQL and already optimized to run that workload. Next, for all of our large instances that take advantage of high availability, you can manage all your high availability SUSE machines using PaceMaker. Finally, one of the largest things that, especially that I'm concerned about, is support. What does it mean for our customers? And what does it mean for our partnerships with SUSE? We want to ensure that we're able to not only work together, but that the customer doesn't feel the pain of going to two different resources. So at this time, I'm going to hand it over to Abby, and she will discuss collaborative support in more detail.
Thank you, Ron. So I want to begin actually by crediting the strong partnership that we have built together. Of course, Microsoft and SUSE have been working together for more than a decade. And Microsoft and SUSE have been working with SAP for more than 20 plus years. This means our mutual customers are going to get the direct benefit of the strong partnerships we have built over time. And then talking about support, customers who are running enterprise workloads on Azure will get enterprise support from both companies 24/7. And growing with Azure is so much easier. We have pay-as-you-go images that customers can use. They just pay for what they have used. And scaling up is so much easier based on your business needs. And scaling down is also much faster and quicker. And then there is Microsoft Enterprise Agreements, also called EA agreements. It gives a lot of flexibility and choice for customers and is also very cost effective. And of course, both Microsoft and SUSE have been continuously working together to innovate and meet customer and market demands. We have the SAP HANA large instance offering that a lot of our customers use, and SUSE is the preferred choice for a lot of our customers. Talking about collaborative support, I'm really proud to say that Microsoft and SUSE have built industry-leading collaborative support to provide a seamless collaborative experience for our mutual customers. What this means is, regardless where the customer has filed their ticket, regardless where the problem lies, as long as the customers are entitled for support from both companies, we will make sure we will bring in the right resources from both companies, and we will work together to drive the issue to resolution. And then we also have on-site presence from SUSE. Grant is here with us today, and he sits with our support team. There's a lot of knowledge sharing happening between the teams, and when there is a need to collaborate together, particularly when there is a high severity issue, production down instances, we immediately gather resources and start working on them as quickly as we can. And we have built a very strong governance model. And what this means is we have frequent reviews that we have built together. We will review all open tickets, make sure we are helping each other to drive them to resolution. We also watch for customer trends. We read them over time and address any documentation needs, training needs. And the feedback loop is quite complete. We study all those patterns, take our feedback, and funnel it back to the engineering team, be it coming up with a new feature from both companies. We also have shared goals that we measure each other upon. Of course, customer support satisfaction is the pinnacle of everything that we do. So we constantly measure each other, and we make any process improvements or tweaks to constantly deliver on our goals. And both companies are really invested in the long-term vision to completely integrate the support experience. This means we want to automate our ticketing systems together so that the tickets can flow in an automated fashion across both companies. We want to build joint tools and diagnostics together so we can take this experience to the next level that benefits our mutual customers. And then for support offerings, we have two primary models. The first one is bring your own model, where we really give the flexibility and choice for our SUSE customers to bring their subscription and run it on Azure. And these customers would typically go to SUSE if they run into a SUSE problem. They would come to Microsoft if they think it's a problem on Azure. But regardless, once they have filed the ticket and they are eligible for support from both companies, we will bring the appropriate resources from both companies and can work together to drive the issue to resolution. For the pay-as-you-go model, this is where customers will use the images from Microsoft. They come pre-packaged with software and support from SUSE. This means these customers need not have a separate relationship or a contract with SUSE. They typically start with Microsoft, and Microsoft will make sure everything on Azure is running fine, and then Microsoft can file a ticket on behalf of the customer with SUSE, and we can bring in the right resources from SUSE to work together and drive the issue to resolution. And then a quick shout out to our SAP HANA large instance customers who are running their mission critical workloads on Azure. Please make sure you have the right level of support agreements with both companies. From Microsoft, we do recommend having a premier agreement so that you get the right level of SLAs and support from both companies. And with that, I actually want to hand over to Rakesh. He has some demos that he wants to share, and of course, a lot of learnings from support experience as well.
Thank you, Abhi. Thank you, Ron. Hello, all. My name is Rakesh. I'm the support escalation engineer at Microsoft. In the next few minutes, we will go through the journey of deploying SUSE Linux virtual machine in Microsoft Azure. Why Microsoft Azure? Microsoft Azure provides low-cost infrastructure resources for all kinds of workloads with built-in security. At the core of the Microsoft, we ensure all the benefits of the cloud computing are broadly shared. Microsoft Azure also provides a rich set of integrated solutions which can be deployed in a matter of minutes, with cloud scale being available in 54 regions worldwide. We collaborate to actually build a trusted, responsible, and inclusive cloud. For enterprise customers, SUSE Linux Enterprise Server has been built to power mission-critical workloads for their on-prem, virtual, and cloud environments. With its flexibility, stability, open standards, and features such as system rollbacks, live kernel patching, and software modules, makes it an easy choice for customers to choose SUSE Linux Enterprise Server for their workloads. With this introduction, let's review the basic OS deployment checklist, which will avoid the most common pitfalls during your infrastructure deployment. As a customer, the first step is to validate whether there is any dependency to use your own image or not. For instance, you may have some application dependencies, or you may have some corporate security rules to harden your image requirements. In those instances, the recommendation is to generalize and then create an image. If there is no such dependency, the recommendation is to use one of the SUSE images from Azure Marketplace. Among the various set of images which are available in Azure Marketplace, they are broadly categorized into two types. One is bring your own subscription, and the other is pay as you go, as Abhi was mentioning before. With bring your own subscription, you can deploy the virtual machine, and then later you need to register your virtual machine using your subscription credentials. That way you are eligible to get the patches from the SUSE repositories. On the other hand, with pay as you go, there is no need for additional registration. Rather, you are eligible to get the patches directly from the cloud infrastructure. Before you make a choice which image to pick, let me share some additional insights. Ask yourself whether there is any dependency to use SUSE products such as like live kernel patching. If the answer is yes, the recommendation is to use the bring your own subscription image. The reason being is, with cloud infrastructure repositories, we don't have the packages such as like live kernel patching. That was the reason that we recommend to use bring your own subscription in that particular instance. Secondly, validate what kind of application you will be running on this virtual machine. For instance, if the end goal is to run an SAP application, the recommendation is to choose SUSE Linux Enterprise Server for SAP. So validate whether there are any images which are available or which are specifically tuned for those applications. And third, among the various pay-as-you-go images, they are broadly classified into three types. One is basic, the second is standard, the third is the priority. With basic, there is no phone or email support, but you are still eligible to get the patches from the cloud infrastructure. With standard, you get 12/5 support, but with priority, you get 24/7 support. So choose the right image based on the requirements. Regardless of whether you pick a bring your own subscription image or pay as you go, I highly recommend to look into the reserved instances. With reserved instances, based on the VM size you pick, you may actually get approximately 50 to 60% of discounted price. And it's pretty trivial to actually create a reserved instance. You go to the Azure portal and buy a reservation, choose the right VM size, and if you prefer that you like to run the SUSE workloads, you will get approximately 50 to 60% discounted price. Once you choose the right image, the next step is to choose the right VM size, which meets your storage and the network requirements. There are specific VM sizes which are specifically tuned for HPC, or it could be for your SAP workloads. There are, as you can see on the slide, there are a few VM sizes which are specifically tuned for the compute, the RAM, or the memory. And you can see there are a few with premium storage being available. Once you pick the right VM size, I highly recommend to use automation for your infrastructure deployments. And this will be the topic for the next few minutes. As a customer, what options do you have to automate your infrastructure deployments in Microsoft Azure? One of the most common options is to use Azure Resource Manager template. These templates are written in the JSON format, and they are easily editable by any text editor. One of the cool features of using this template is that the platform understands its dependencies and can create the resources in parallel wherever it is possible. The other option is to use one of the open source tools from HashiCorp, which is Terraform. With Terraform, you define the configuration in the very same way you would define with the resource manager templates. You define what all components you would need to build your infrastructure. For this session, we will use Terraform as our tool to deploy SUSE Linux virtual machine in Microsoft Azure. So what steps are involved to deploy a SUSE Linux virtual machine in Microsoft Azure using Terraform? The first step is to have the right authentication so that you can create the resources in Microsoft Azure. Terraform tool allows several methods of authentication. One is like if you use Azure CLI, or you can go to shell.azure.com. The second option is to use like managed service identity. And one of the most common popular option is to use the service principal with either a client certificate or a client password. Just in case if you're not familiar with the service principal, tools, automated tools such as like Terraform, right, having elevated access is not a recommendation. So rather, Azure provides service principals which can create resources on behalf of those automated tools. On this slide, what I'm showing you is how to create the service principal. So among these various authentication methods, let's say you want to actually choose service principal with a password. That's your way of authenticating. In this instance, we are using AZ, which is the Azure CLI. It's basically a CLI to manage your Azure resources. AD stands for the Active Directory. SP stands for service principal. You're creating a role-based access control with the role contributor. Once you run this command, you will get the app ID, password, the service principal name, and the tenant name. You will use this configuration information when you define your Terraform configuration. That way, it knows that you have the right authentication to create the resources. Once you decide on the authentication method, the next step is to have or create the configuration file defining what all components you would need to build your virtual machine, or it could be your entire data center. These configuration files can be either in one of the two formats. The most popular one is the HashiCorp configuration language, and the other is the JSON format. Once you define the configuration file, the next step is to run Terraform initialize. It basically initializes all the local settings or the data which is required by the subsequent commands. And it also actually pulls providers which are defined in that in the previous step, that is the configuration. And then you run Terraform plan to preview the actions which Terraform will be doing on behalf of you. Once you validate the plan, and once you review what all resources it's going to create, the next step is to run Terraform apply. For the purpose of completion, if you want to destroy all your infrastructure, which is defined in the Terraform configuration file, you run Terraform destroy, which basically goes and destroys or deletes all the components which are defined in that particular configuration file. Moving on to the demo. In this instance, I'm creating a new workspace known as SUSECON demo. Right now, it's creating a new workspace, which is SUSECON demo, which basically allows you to store the persistent data, such as like Terraform state. And then we create the configuration file. For the purpose of this demo, I'm actually using one of the Microsoft templates, but we will go through the configuration in detail in the next few minutes. Once we define the configuration file, the next step is to actually run the Terraform format, which basically reformats your configuration file in a more canonical way. And then once you run the Terraform format, the next step is to run Terraform initialize. In this instance, as you can see, it's actually pulling two providers, Azure RM and the provider random. And then Terraform plan tells me what all resources it's going to actually create under my subscription. In this instance, it's creating 9 resources. Once I validate it, I'm saying Terraform apply. And then it's going to start creating the necessary resources under my subscription. While Terraform is actually doing the heavy lifting of creating the necessary resources, let's review what exactly we define in the configuration file. So this is the configuration file which we are using in this particular demo. As you can see from the configuration file, there are several sections. The most important ones are the provider section and the resource section. Terraform actually uses a plugin architecture. In this instance, provider can be a cloud service provider. We are actually using the Azure provider, which is named as Azure RM. For the purpose of completion, if you like to deploy the workloads on any other cloud providers, you can check out the Terraform documentation, whether there is a provider available for the corresponding cloud vendor. And then the next sections are the sections which list what all resources you would need to create the virtual machine. Before you create a virtual machine in Microsoft Azure, there are several other resources which needs to be created first. Among them, few are the resource group, the virtual network, the network security group, the network security rules, the storage account, just in case if you like to store all your console logs, and the virtual machine itself. The first section where we are defining provider Azure RM, so it knows that way to actually create the resources under my subscription. Moving on to the second section, which is the resource Azure RM underscore resource underscore group. The syntax is resource, the resource type, and the resource name. In this instance, the resource name is my Terraform group. And the resource type is Azure RM underscore resource underscore group. The name and the location are the attributes which are defined in the resource section. And then moving on to the next resource, in this instance, we are actually creating a new virtual network. And you can see new syntax has been introduced in this particular section. There are square brackets where we are defining defining for the attribute address underscore space. Basically, square brackets allow multiple values. In this instance, we are actually using only a single value. And the other most important syntax is check out the resource underscore group underscore name. You can see the Azure RM underscore resource underscore group, that's the resource type. My Terraform group is the resource name, which is defined in the previous section, if you recall the syntax. And then we are calling the attribute from that particular resource, which is the name is the attribute. You're basically calling the attribute, the name, the value of the attribute from the previous resource. This syntax is known as interpolation, which is commonly used in most of the Terraform configuration files. You will see this syntax being used in the rest of the configuration as well. And then the next section is defining how to create the subnet. And then we are creating a public IP address so that we can log into the virtual machine with the public IP address. In this instance, we are creating a new security group with the rule saying that I would like to allow SSH traffic. Based on your requirements, you can actually open up several other ports to access your virtual machine. If you're running a web server, you may want to actually include to open up the port 80 or 443, depending upon your requirements. And then this resource block is creating the network interface. And then we are leveraging the random provider so that we can actually create a unique storage account for the boot diagnostics. It's like you can store the console logs, which is a very helpful feature in Microsoft Azure portal. And then the important section is the virtual machine. In this instance, if you see the storage underscore OS underscore disk, we are naming the name. The caching is the read-write. That is the caching mode we are using for the OS disk. And we are saying create from the image, and the manage this type is the premium LRS. LRS is for local redundant storage. There are several other types of storage types. If you would like to actually have geo-redundancy, then you need to pick GRS. And the storage image reference in this instance is the publisher is SUSE, and the offer is /priority. If you recall the previous discussion, I was referring basic, standard, and priority. With priority, you get 24/7. In this instance, we are picking the priority image. The SKU is 12 SP4. You can actually choose the right SKU depending upon your requirements. If you need 15, or it could be 12 SP2 based on your application requirements. And there is also a version tag. In this instance, we are picking the latest one. But if you have any dependencies to choose any of the older versions, then you can specify that particular older version as well. And then for the authentication, in this instance, we are using the SSH keys. I'm using the public key, which I have so that I can log into the virtual machine. Based on your requirements, you can use the other authentication methods as well. And that completes the configuration review. As you can see on the demo, the virtual machine has been completed. Now you can see the newly created virtual machine has an IP address 40.117.76.195. We are trying to log in to the newly created virtual machine. As you can see, we are up and running. And the uptime. And we can check the OS release in this instance. So this completes how to create a new SUSE Linux virtual machine in Microsoft Azure using Terraform tool. So as you can see on the Azure portal, this is the Azure portal where we created the new virtual machine. This has the OS disk, which we used. Now I would like to actually add data disk. How many of you want to actually use Portal to create a new data disk? I'm not a big fan of actually using Portal or GUI to actually do all my infrastructure work. Rather, I would like to have code, like infrastructure as code. That way, I know what is defined under my infrastructure. So since my next requirement is to actually add data disk, let's actually use Terraform to actually add the data disk and attach to the virtual machine. So let me take a quick look. And if you're not familiar, this is shell.azure.com. So instead of having Azure CLI installed on your local workstations, you can actually use shell.azure.com. And the shell itself actually has like Azure CLI built into it. There is no need to actually install Azure CLI. And for the purpose of completion, even Terraform is actually built into the Azure CLI at this point in time. Hopefully this works. And the demo gods actually will be with me. OK, not bad. So this is exactly the configuration file which we used for this particular demo, where we defined or created the SUSE Linux virtual machine. Now, you can see I have two separate sections where it lists create the data disk, and then we have the attached data disk. We will get to this particular resource in a bit. What I will do is, let's run. As I know that we already defined the configuration file to create the data disk and then attach the data disk to the virtual machine. Let's run Terraform plan and see what exactly it actually says. Oh, looks like a fat finger. That looks pretty slow to me. And it should, in this instance, oh, I think I have fat finger, but let's make sure I run that one more time. But you can see in this instance, it's saying that it's going to create 2 additional resources. One is the disk itself, and the other resource is attaching the data disk. And since I know that this is exactly what I need based on my requirements, let me apply that. And then running Terraform apply. And yes. And Terraform will go ahead and create the data disk, and it will attach to the virtual machine in the next few minutes. Let's quickly review the configuration while it's actually doing the heavy work. Okay. So in this instance, we are creating the resource data disk as I was referring. I have the name, and we are using the interpolation syntax to get the values from the other resources. We define the location, and we have the storage account time to be defined as standard LRS, and we define the data disk size to be 100 gig. The next resource is actually saying to attach the data disk. Rather than just creating the data disk under my subscription, it's going to actually attach the data disk. And we are defining to which virtual machine I need to attach my data disk. In this instance, the LUN ID is the 10, but and the caching is the read write. With that, you can see it already, Terraform went ahead and created those 2 resources, and it added. Now, just to validate, before I showed you that in the portal.azure.com, we did not have the data disk before. Now it's already attached to the virtual machine and up and running. Deploying the infrastructure in on-prem world is very complex. It could actually take several weeks of planning, or it could actually take several months of planning with a lot of resources being involved. But deploying the very same infrastructure on cloud environment with the right tools is very fun, it's cost effective, and it's going to actually save a lot of time cycles. With that, I would like to ask my colleague, Grant Marcroft, to join this session. Thank you.
Hey, thanks, Rakesh. Thanks, Abby. Thanks, Ron. All right, so give me just a second to go through this real quick. Oh, there we go. All right, so I'm going to go over just a few different workloads that are available on Microsoft Azure to run your services. We'll start off with one of our core products, as has been mentioned a little bit earlier. This is SAP has been a very special company to us, and we've harbored a relationship with them for many years in order to make this possible. Then I will go over expanding on your Azure with the SUSE Manager, and then looking beyond just SAP with high availability extension. In general, SAP, when deploying SAP, it takes a great deal of time, planning, and resources, particularly when it comes to deploying the HANA database with its large requirement of physical memory. By using Microsoft Azure as your SAP provider, you can greatly reduce the total cost and overhead with setting up these complex SAP landscapes. Virtual machines can be set up in just a matter of minutes, and large instances, large physical servers that are made specifically to host your HANA applications are set aside for customers to reserve so they can have the full hybrid experience running their HANA and SAP workloads fully in the cloud, as far as how the customer sees it. Azure is also an SAP certified platform. But outside of just the engineering part, what really makes running your SAP services in Azure a unique experience is the collaborative support. If you have an on-demand image, you just have to put in a ticket with the Azure team. If it ends up not being an Azure issue, they will work on engaging the resources to make sure the issue is driven to a resolution. This really helps because I'm not sure how many of you have worked on the other side of a support phone call where the vendor says, "Oh, well, that's not our problem. You're going to have to talk to this other vendor." That this can be something that is very discouraging for a customer, and so having this integrated support with SUSE and Azure really helps with making driving customer satisfaction. Now, the development of having an on-site engineer such as myself in Microsoft is a brand new thing. I've only been in my current role for about 6 months, but as our relationship strengthens with Microsoft teams, not only are our customers going to benefit from this, but our engineering teams from all three organizations will be able to lean on the expertise and talent of the Azure support teams. Right, now, moving on. So with on-demand images, they have the ability to get their software from our public cloud infrastructure. This is all managed by our public cloud engineering team. SMT servers are set up in local regions to be able to provide software for these systems. Now, this system works great for small deployments, basic workloads, and temporary systems such as QA and development that don't have any very specific requirements. But as your infrastructure expands to dozens or hundreds of systems, this becomes very unscalable very quickly. So with SUSE Manager, it has been a product that has been developed actively for over 4 years and has had 5 major revisions already. Not just that, but many SUSE administrators are already using SUSE Manager to configure, maintain, and manage their SUSE and other infrastructure. With SUSE Manager, you're able to bootstrap not only the bring your own subscription systems, but also pay-as-you-go on-demand instances direct from Microsoft. There are 2 images that are available in the Azure Marketplace, as well as all of our other cloud providers. Those are the SUSE Manager Server and the SUSE Manager Proxy. So this means our customers have 2 ways of using SUSE Manager with their Azure subscription. They can either deploy the proxy in the local region that they would like to use with their Azure cloud, or going one step further, they can deploy their SUSE Manager server in the cloud. So with the proxy, you can maintain your currently configured SUSE Manager that may be on site, but with the server, that allows you to keep that allows all of the that allows you to go to Microsoft in the case of any kind of infrastructure issues. Of course, if it is a SUSE thing, you definitely want to go directly to SUSE for the support for that. Right. One other benefit of using SUSE Manager is there are certain limitations with the on-demand images, like getting specialized software. With SUSE Manager, you're able to bootstrap these systems so you can get specialty software not normally available for all of our images, such as the high availability extension. High availability extension has been used extensively with SAP deployments for many years in order to manage the failover of these systems. With high availability, though, it's not just useful for SAP. Anything that runs native on Linux can have failover managed by our high availability extension. In fact, there is an OCF resource called anything that takes an argument, or that where you can give it the path to a binary, and as well as provide it command line arguments if something does fail over. Of course, as long as the high availability configuration is set correctly, services should be able to fail over to other systems in case of a known failure. So right now, if you don't have a SUSE Manager, the way to run your highly available services in Azure is by spinning up a bring your own subscription image. Bring your own subscription images run off of the standard SUSE infrastructure, so you would register one of these instances just the same as a system that you might be hosting on site. This will allow you to register with any kind of specialized entitlement. All right, so that's the high availability extension portion of this. Now, all these services are great and can be used to host your systems, but what happens when something goes wrong? As a support engineer, that is my business. I'm the guy who people call when something goes out. I usually don't hear from customers if things are going right. So, if you deploy in Azure, you should know that you will receive the same level of support through Azure, whether directly from SUSE or indirectly. Escalations will come to me. I will be able to handle them. If a subject matter expert is required in order to get to the bottom of it, I can engage resources within SUSE to make that happen. So I've only been with Microsoft for about 6 months, and we've already had many success stories. I'd like to share just 2 of those today, 2 that have really stuck out to me as great examples. So bright and early on a Tuesday morning, I received an email from Rakesh. One of his customers was trying to set up an iSCSI LUN using SLES12 SP4 using the Azure kernel. The iSCSI Atom command came back with a fatal error for stating that iSCSI_TCP module not found. Rakesh did some preliminary checks. He looked in the module directory and was able to find that, in fact, the module was missing. He informed me, hey, I think we're looking at a bug. So at this point, with me being a technical guy, I was like, okay, well, maybe he's missing something, maybe there's something else to this. So I spun up a SLES12 SP4, installed the Azure kernel, took a look at the modules directory, and confirmed that the iSCSI TCP module was not included. I then checked the Azure kernel on SLES12 SP3 and found that it did in fact have this module. At this point, I worked with our engineering team. I contacted them and said, hey, it looks like we have a bug on our hands. I just want to give you guys a heads up. One of the public cloud guys got back to me and said, hey, the Azure kernel is actually tuned for performance reasons, reduces boot time, so there's a good chance that if you don't have a specific feature, it might just be intended behavior. I then said, okay, well, this person trying to set up an iSCSI1, I don't see anything that says that we drop support for setting up iSCSI storage in SLES 12 SP4. He then proceeded to ask, okay, well, is this affecting a customer? I confirmed, so he directed me to file a bug. As soon as the engineering started looking at it, they found that, in fact, a configuration parameter for the kernel, config iSCSI TCP, had been set incorrectly. They then updated the code, and the next day, the published Azure kernel had the fix available. From the beginning of the engagement to the fix in the code, to the point where the kernel was published and available to all Azure customers, we're looking at a turnaround time of less than 48 hours. When I received the email, I sent that out. There was about 3 hours before I filed the bug, and it was fixed, of course, with a lot of our engineers being in Germany. It was taken care of pretty much in the middle of the night from how we perceive things. So this goes to show how dedicated resources with Microsoft or with Azure can help to identify these issues very quickly, submit bugs if defects are found, and can in turn strengthen our products. So the next example I would like to share did not go up to engineering. It was a case where a customer had a system down issue. This happened just before weekend, and so this will highlight the great support and the collaboration between the Azure Rapid Response team and our SUSE support. So right around 11:30, I believe, on a Friday, I received an email, hey, we've got this system down, we need to get you on a bridge call, we need to get this thing back up. Thinking, okay, this is a Friday, it's 11. I wonder if I have any weekend plans that I got canceled. If you've ever worked in some kind of a dedicated, contracted support role, this is normally something that would go through your mind. So, of course, I called into the bridge and I started trying to work out the issue. What had happened is they had gone for a reboot, and when as soon as the system got past the hardware checks, the post phase, it wasn't able to find the operating system. So, working with support and working on a whole lot of boot issues, I thought, okay, well, normally if something fails at this phase, we're looking at a bootloader failure. So I directed them to boot up to the installation media and open up the rescue system so we could load a working system and take a look at what was happening, take a look at the storage. When, as soon as I pulled it up, we took a look at the disks, and the disk that was supposed to contain the root partition was completely devoid of partitions. From the perspective of the system, there was no data. At this point, normally, well, at this point I was thinking, it looks like the data was somehow deleted. I don't know what happened, but it looks like you guys are going to need to redeploy. The customer was not thrilled with that answer and said, surely there's something you can do. The system was working fine. We had applications running on this, and the only thing that changed is we rebooted the system. So thinking about it for a second, I thought, maybe there was a problem with the master boot record. If you guys know what the master boot record is responsible for, not only does it define the partition boundaries, but it's also where the grub boot.image is embedded in order to bring the system up. So I thought, okay, well maybe this was corrupted. What I did is I took a hex dump of the first 512 bytes of the disk, and what you will see right here is what I found. exactly like this, just a whole bunch of eyes. I don't know what would cause that. Maybe someone fat-fingered an iterative loop, but this would not only explain the fact that there were no partitions, it also explains the boot issue in hard data. So at this point, I've worked on a lot of these, and if I know that if we can just recreate the master boot record with the same partition boundaries, reinstall the bootloader, the system should work again. It should boot. So normally a copy of the master boot record is stored under /boot, but with the partitions being pretty much inaccessible in this stage, that wasn't an option. I then asked, okay, was there a backup taken of boot? I received the reply, no, there was no backup of this. So then I asked, okay, Rakesh, do you know if this is is this its own system that was a custom configuration, or is this one of many different systems that were configured in the same way? He worked with the customer and was able to find that there were several HANA large instances that were configured with identical partitioning. And then asked him to get the output of the fdisk-l command. With that, using that as a template, I used fdisk to write a new boot label, then define partition boundaries at the same sector numbers. After this, I took a look at the sizes of the partitions. SDA2, the second partition, was the largest, so I assumed, okay, this one might be root. I went to run the mount command, mount dev sda2/mnt, went to hit the enter key. The enter key was pressed, the prompt came back, no errors. So this was a great sign. I then proceeded to look into the /mnt directory to see whether we had good data, and I was able to confirm that the root partition was intact. I then checked. I looked at the first partition. It was about the size of what I would expect from a boot. So I mounted that under /mnt/boot just to verify, make sure everything was good. With something like this, you have no idea how far into the disk this might have gone. Normally, the default partitioning starts on sector 2048. If it overwrote any of the beginning of that first sector, it might have wiped out some of the file system metadata. So I mounted boot. Everything came back great. I looked at the file listing, and I saw the boot data as well as kernels. So at this point, I saw this as a win. Said, okay, let's reinstall the bootloader and see if this thing comes up. Ran grub to install /dev/sda, enter, reinstalled, and then said, okay, let's reboot this thing. So the system goes down, comes back up. Post phase takes a while because we're talking about a terabyte of memory. Goes through the hardware phases, and at the very end of the hardware checks, I saw my weekend come back to me. The beautiful view of the SLS 12 grub menu with the kernel list. The list timed out. I watched the cascading boot logs, and there was a small failure with the swap as it was coming up. But now that the system was online, that was really quick. Once all of this finished, I asked the customer, okay, can you verify that everything's working? All of the software was working fine. We had taken care of the issue. Now, from start to finish on this, I think I was engaged. I was brought onto the phone call sometime around 11:30. Finished off around 1:30, 1:45-ish. If we went with the original option of rebuilding, this was reported right before a weekend. I'm not sure if more than one system or more than one team would have to be engaged. There's a good chance that the customer would not be able to get all the proper resources to get this taken care of before the next, the following week. So not only did this save the customer a great deal of time, money, and unnecessary work, but it gave them confidence that SUSE and Azure together can take care of these more difficult support issues. So now,
did you ever figure out why the master record failed? Because if you put it back in the same spot, it's get corrupt again.
That's a question.
that is a great question. I looked into it, but we weren't able to find anything. I was thinking maybe it would be in the bash history, but I really don't know what caused that. But yeah, actually, perfect timing.
And they did a backup.
This is
got it up.
absolutely. But yeah, so now we're gonna have our QA session. Thank you for your first question. Yeah, if you have any questions for any of us, now is the time.
Okay, first question. If I try, can I do SUSE installation by the way that I do in my computer on premise? Like have an image and then try to install the ISO? And should I have to load the ISO to do this kind of installation, or is Microsoft already?
To my knowledge, I believe I just want to verify if an image is needed to be uploaded.
So, in general, there are several Azure SUSE images in Azure Marketplace. You just choose one of the existing images, and then you can create the virtual machine. If there is any dependency to use your own image, then you upload your VHD, and then you can create images of virtual machines of that image. So it could be one or the other.
So it's on the basis of Hyper-V.
So underlying, it's actually Hyper-V, yes, hypervisor. Yes, that's correct. But you can.
So I had two questions, both kind of around your presentation. The first is it was my understanding that in Azure you could not actually get console access, like boot from an ISO image and get to the console. But sounds like you're able to do that in this situation.
Is this related to the incident or the success?
That's what made me think of
Okay.
it, yeah.
So that particular instance is related to the large instance, which is a physical server, and we do have the management console access, only the operations
But
team.
not on a VM.
No, actually, we do have the console on VM.
Oh, you do?
Yes, there is a serial console available, and let me show you right now. Which is a great feature, just in case if one of your virtual machine is stuck in a non-bootable state, you can actually use the console to fix the problem. While it's loading up.
I can ask you a question while we
Yes,
show
sure.
that.
Sure.
With SUSE Manager, could I actually do an auto YAS deploy the way I do locally, rather than use the image?
I believe so. I need to double check on that though. I know that it is responsible for configuration management, but
I know on the side I can fix it into the VM and just play that with auto YAS.
I actually haven't tried that. So if you'd like, if you want to give me your information, I can look into that. I'll talk to the SUSE manager specialist.
Can I expand on this first question? You talked about like the ISO and mounting. So far for your example, for anybody but the rest of you. That's something that to me is religious that I have that functionality because in Azure we've had to do some recoveries. And the way we get around not being able to mount the ISO was we have another VM already built we call a recovery VM. And it has just a basic SUSE install, and then we would, take the disk and detach it from the broken VM and move it over, and that's a very cumbersome process. So my question was kind of, with the serial console, I mean, it's great. that's an awesome feature. I've paid for that for a little bit.
Okay.
So if that helps a lot. But then the problem is, if I need to get into rescue mode, I'm still with a very cumbersome process. So are there any plans for, to try to introduce a way to at least, maybe not free form, not whatever you want, but at least with like pay as you go templates, offer a feature where we can, I need to mount up immediate, but I need to get to a rescue mode. I know that's a challenge with the serial console.
Okay. So let me divert that question to the folks in the Microsoft booth. I know there's a product group engineers who actually has a session or a demo on how to actually use the console. If you can bring that question to the booth engineers, they can actually take that feedback to the product group.
Okay.
But I definitely I appreciate you bringing this question here. Thanks.
So you mentioned the high availability extension. It sounds like that requires a subscription rather than pay-as-you-go license.
Yes. So, well, with SAP, it comes baked into the product, so you have that available. But with anything, if you're not using an SAP specific image, you will need to go with the bring your own subscription, unless you're using a SUSE manager.
Are there other scenarios that require that the pay-as-you-go image doesn't screw your stuff's not available?
Anything that requires a specialty entitlement. I know live kernel patching is one of them. I think if you wanted to set up like a SUSE storage, SUSE enterprise storage, you would need to have a subscription with us directly. The thing with the on-demand images is it allows those images are indirect to SUSE. We have no idea. That's all managed on the Microsoft end, and we don't have any relationship with the customer. But the escalation process goes through me, and then I work with other engineers as needed. So the bring your own subscription allows us to verify the registration process.
So I'd like to thank everyone for your time. We're actually out of time now, but we'll be downstairs at booth 301. If you have more questions, please come see us, and we'd love to have you.
Thank you.